you are moving with the same speed. Okay, you are moving with the same speed. That speed will be uniform speed, means your speed is not changing. Average speed means I have defined here average speed. Speed is known as the total distance divided by the total time taken. Total distance divided by the total time taken. And we have done questions on average speed. After that, we have discussed velocity. So basically, velocity is speed with direction. Suppose you are going towards north with 5 meter per second. Okay, if you are saying 5 meter per second with direction, then that will be your velocity. Like speed is equal to distance upon time, no? Velocity is equal to displacement divided by time. Okay, velocity is equal to displacement divided by time. So basically, the magnitude of is velocity is speed. Okay, so speed, magnitude, and numerical value of velocity. So if I am taking the example of 5 meter per second towards north, so means this will represent the velocity because direction is involved here along with the numerical value. So here, if you will talk about this numerical value only, then you will say this numerical value will be known as the speed or magnitude of velocity or numerical value of velocity. And north, we know, no, east, west, north, south, these are directions. So velocity, I have defined two ways. Uniform velocity means you are moving in a straight line like this. You are moving along east direction with 10 meter per second. So your velocity will be uniform velocity. Non-uniform velocity means changing velocity. You are moving with 10 meter per second. With 10 meter per second, first towards east, then you have taken the turn, then you are moving towards south. Okay. And suppose another example. This is example one. Example 2, you are moving from A point to C point, and from A to B you are moving with 50 meter per second. From B to C you are moving with 10 meter per second. So here also you can say your velocity is changing. Here your velocity is changing due to the change in the direction. Here your velocity is changing due to the change in the magnitude of velocity. Now after that, non-uniform velocity, I have elaborated the non-uniform velocity. Non-uniform velocity can be measured in terms of average velocity, and we know that average velocity, like the average speed, the average speed is total distance divided by total time. So average velocity is total displacement divided by total time. Instantaneous velocity, I have told you, velocity at an instant of time. Okay, velocity and instant of time. And instantaneous velocity is defined as instantaneous displacement divided by instantaneous time. So Rayyan, these things we had discussed in the last class. Okay, so I think now I should continue. Okay,
Yeah, okay.
fine. Now there is one more term. There is one more term, acceleration. There is one more term, acceleration. Acceleration. And acceleration is represented by A. Okay, and this small a I will represent acceleration. Now what is acceleration? So acceleration is change in velocity divided by change in time, or you can say time. For example, You have started the motion from A point, and finally you are moving in this direction. And at point A, suppose your velocity is small u at this point, at A point. At B point, suppose your velocity is small v. And time taken in going from A to B is small t. So your acceleration will be change in velocity. Change in velocity means final velocity minus initial velocity divided by time. This is the acceleration. Okay, this is your acceleration.
Yeah, okay.
Yeah, this v minus u is change in velocity. This v minus u change in velocity. For example, in here your speed suppose is 50 kilometer per hour. For example, here your speed is 60 kilometer per hour. So what is the change in velocity? So one thing more I want to tell you, uh, change we will represent with delta v. Okay, this is known as the change. What will be the change in velocity? Forgot that delta v. What will be the change in velocity from here to here? You will subtract this 50 from this 60.
Yeah.
60 minus 50, that is 10 kilometer per hour will be the change in velocity. Suppose if time taken is 2 seconds, so we can calculate the acceleration easily. So acceleration in that case will be 60 minus 50 divided by time taken is 2, that will be 10 by 2. Okay, so this will become 5. Okay, here we have to I am just changing the unit. Your speed is 50 meter per second. No problem, we can change the unit also. 50 meter per second. Okay, so we have the acceleration 60 minus 50. So you are on a bike and you are just accelerating your bike, means the speed or the, you can say, the velocity of the bike, velocity of your bike is increasing. Okay, velocity of your bike is increasing. So velocity of your bike is increasing. That's okay. Suppose when you have applied the brake, so what will happen? The velocity will increase or decrease? When you have applied, decrease, no?
Yeah.
Very good, very good. Decrease. So when your velocity decreases, okay, when your velocity decreases, that thing is known as the retardation. There is one term, retardation. When velocity decreases with time, this retardation is also known as negative acceleration.
Okay.
So why I am saying this is negative acceleration? Suppose initially you are here and you are moving from this A point to B point. At A point, your speed is 5 meter per second, and at B point, your speed is 4 meter per second. So, and time taken is 2 seconds. Now, what will be the change in speed? Always remember, change in speed, you will write first final speed, then the initial speed. First final speed. This is your final speed. This is your initial speed. Okay. So acceleration will be 4 minus 5 divided by 2. This will be minus half. So that is why I was saying acceleration is negative. Means this A is minus 1 by 2. So this is negative acceleration. So we will say this as retardation.
Okay.
And right here, unit of acceleration. I am talking about the international system of unit as a unit is meter per second square. Okay, how can we calculate the unit? We know that acceleration is equal to change in velocity divided by time. So unit of velocity is meter per second and unit of time is second. So it will become meter per second square. Okay. It's fine?
Yeah.
Okay. Now we will take one question. Okay, we will take one question. Okay. So before taking the question, I want to just introduce some equations of motion here. Okay. I want to introduce some equations of motion. So motion. Acha, if I will say acceleration is uniform acceleration. If I will say uniform acceleration. So uniform means same acceleration. Acceleration is not changing with time. Or uniform acceleration is also known as constant acceleration. Constant acceleration. Okay. Constant acceleration. Okay. So constant acceleration. So now I will take one example of this constant acceleration. Suppose you are moving from this point to this point in a straight line. You are moving from this point A to the point B like this. This is point C and this is point D. So at A your speed is 10 meter per second. At C your speed is 20 meter per second. At D your speed is 30 meter per second. At B your speed is 40 meter per second. Okay. And in covering the distance A to C, you are taking 5 seconds. Here also from C to D, 5 seconds. Here also from C to D, 5 seconds you are taking. So this is we will see, is this the example of constant acceleration throughout the journey? Okay, we will see. So now calculate the acceleration of motion from A to C. Acceleration in going from A to C. What is the acceleration in going from A to C? Change in velocity divided by time.
Yeah.
So what is change in velocity? 20 minus 10. Change in velocity will be final velocity, that is 20 minus 10 divided by 5.
Yeah.
So this will become 10 by 5. This will become
Hmm.
2 meter per second square. Now we will calculate acceleration in going from C to D. So see the point C and D. Now here your final velocity will be this
Hmm.
and initial velocity will be 20. So in other words you can say what is the change in velocity from point C to D? 30 minus 20
Hmm.
divided by 5. This will again 10 by 5. This will again 2 meter per second square. Now D to B. D to B. Acceleration from D to B is equal to, now change in velocity from D to B, final velocity minus initial velocity, 40 minus 30
Hmm.
divided by 5, 10 by 5, that is 2 meter per second square. Now you can see here acceleration is constant throughout the motion. So this is the example of uniform acceleration. Okay.
Yeah. Okay.
Now we will discuss the equation of motion. So equation of motion. First, we have three equations of motion, and these equations of motions are valid only when the body is moving in a straight line. When the body is moving in a straight line, equation of motion for body or particle, you can say, moving along straight line and these equations of motions are valid when acceleration will be uniform. Acceleration will be uniform. Uniform means constant acceleration. Constant means acceleration is not changing with time, like here. Okay. Now, first equation, V is equal to U plus AT means this is point A and this is point B. You are moving from A to B. In moving from A to B, time taken by you is T. U is your initial velocity, V is your final velocity. Okay. What is U here? U is your initial velocity. What is V? V is your final velocity. What is T? Time taken in moving from A to B. And what is A here? A is representing acceleration. A is representing acceleration and that acceleration is constant. Okay, second equation of motion. S is equal to ut plus half at square. Suppose this distance is S. This S is a displacement basically. Okay, you have started the motion from this point A. Okay, and you have covered the S displacement. S displacement you have covered in time t. Okay, and your initial velocity is u. And your initial velocity is u. And throughout the motion, your acceleration is 8. Okay, so you can use this equation of fine. What is this S? S is this distance.
Hmm.
This,
Yeah. Okay.
or you can say displacement also.
Hmm.
Okay, just one thing should be clear when a body is moving from here to here. This is the initial position of the body, this is the final position of the body. And the body is moving from this initial to final position. So suppose this is 10 meter. So in this case, what will be the distance? Ryan, distance?
10.
Very good, 10 meter. What will be the displacement?
Uh, 10 over 2.
No. Displacement will also be 10. Because
Oh,
what I have told you for the displacement, I have told you displacement is the straight line,
yeah,
straight line distance from initial to final position. So
yeah,
straight
okay,
line distance is 10 from initial
yeah.
to final position. So
Hmm.
displacement is also 10. So there is a note point you can write here. When the body is moving along a straight line in same direction, distance is equal to displacement.
Okay.
This body is moving in a straight line. So you can write here, when body is moving along straight line, in that case displacement is equal to distance. Now third equation of motion is v square is equal to u square plus 2as. What is s here? S is the displacement. Now initially you are at a, finally you are at v. Initially your velocity is u, not v. Initially your velocity is small u and finally your velocity is v. Okay, so in going from a to v, you are going from a to v, time taken by you is t and distance or displacement covered by you is s. In that case you can use this equation. Okay. In that case you can use this equation.
Okay.
So do you want to copy it or note it down?
Can I take screenshots of it?
From in the previous class, have you taken the screenshots?
I took some.
Some. Now
Yeah.
take all these screenshots. Otherwise, you will not understand what I want to tell you.
Sir, is there a way you can send this to me or anything? Is there a way you can send this to me?
Okay, I will try.
Yeah, okay. That'd be better.
Okay. But at least you should take one notebook now with you and a
Yeah.
pen with you. Okay.
Yeah, I have one.
Okay, just wait a minute.
Yeah, okay.
Okay, so these three equations of motion you should know. Number one is equal to, number one is V is equal to U plus AT. Number second, S is equal to UT plus half AT square. Number third, V square is equal to U square plus 2AS. And these equations are valid where acceleration is constant. Okay, so we will solve one question. A body starts with velocity of 2 meter per second and acceleration of 5 meter per second square. Calculate velocity at time 3 seconds. Second, displacement in 5 seconds. Number third, we will calculate displacement when velocity is 20 meter per second. So see, one by one we will solve, one by one. Okay. So a body start with a velocity of 2 meter per second, means suppose this is one body here, and this body starts with a velocity of 2 meter per second. I have told you what is u? U is the initial velocity. I have told you we will represent initial velocity with u. Here, this u will be the initial velocity. Okay. And this velocity is moving like this, and acceleration of this body is 5 meter per second square. 5 meter per second square. So this information is given. Initial velocity of the motion is given of the body, and acceleration with which the body is moving is given, and this acceleration is constant acceleration. This acceleration is not changing with time. So we can use these equations of motion. We can use these equations of motion. First, we have to calculate the velocity at 3 seconds. Velocity at 3 seconds. Okay. So suppose initially your body here and finally at 3 seconds, at t is equal to 3 seconds, your body is at point B. Suppose initially at point A and finally at point B. Okay, and at this point the velocity of your body is suppose B. Okay, and acceleration is 5 meter per second square. Acceleration is 5 meter per second square. So we can use this equation, v is equal to u plus at. So we can find this velocity v, final velocity. Initial velocity is given as 2 meter per second. So this is 2. What is acceleration? 5. What is time? 3. So we will get 2 plus 15. So finally what we will get? 17 meter per second. So what this will be the velocity at 3 seconds. Got it? Rayyan?
Yeah.
Rayyan, have you sent me the book that I have told you to send me?
No, sir, I couldn't get it.
Okay.
I'll get it on Sunday.
Okay.
Monday.
You will get that book on Sunday.
Monday.
Monday.
Yeah, tomorrow. Today
Okay,
Sunday.
so
I'm not giving you
Monday you should send me that. Okay.
Yeah, okay.
So now we will solve the second part. So in second part, they are asking this: what will be the displacement in 5 seconds? Displacement in 5 seconds. So this condition is given again. Initial velocity is given, acceleration is given. So they are asking, suppose initially your body is at A and finally your body reached at point C and covers the displacement of S, and time taken in moving from A to C given as 5 seconds. So in these 5 seconds, what will be the displacement covered by the body? We will calculate. So we will apply this equation. S is equal to ut plus half at square. So what is S? S is the displacement. Okay, so we will apply this. So what is initial velocity? 2. Time is 5 plus half. Acceleration is 5. T square means 5 square. So you will calculate it. This will become 5 to the 10. This will become 125. This will become 2.5. This will become 5 by 2 is 2.5 multiplied by 25. So it will become 10 plus 62.5. So this will become 72.5 meter. So what will be your displacement? 72.5 meter. Now third part, they are asking displacement when velocity is 20 meter per second. Displacement when velocity is 20 meter per second. Third part. So here this condition is given in the question. Initial, this is the initial velocity. This is the acceleration. So now they are asking the displacement covered by the body when the velocity of the body becomes 20 meter per second. 20 meter per second, na? 20 meter per second. So suppose s distance is covered by the body. S is the distance covered by the body. So we will use this equation: v square is equal to u square plus 2as. This is third equation. This equation we will use. With practice, you can also solve these questions. So what is v square? This 20 square. What is u square? This 2 square plus 2 into acceleration is 5, and s we have to find. So this 20 square will be 400. This 2 square is equal to 4. This is plus this 5 to the 10s. Okay. So this will become, this 400 minus 4 will become 396. This will become 10s. So from here we can calculate s. 396 divided by 10. So you will get 39.6 meter. This will be your displacement.
Okay.
So I think you should write these equations of motion on your copy.
Okay.
For practice. And Rayyan, which chapter is going on in your school?
Forces.
Okay. Have you completed this kinematics?
No, I'm writing in that.
Hmm?
Where the topic? Which one?
Yeah. Have you this topic, na? Speed, velocity, distance, displacement. This has been completed or not?
We did displacement, but we didn't do speed and velocity.
Okay.
Okay, sorry, I wrote it down.
Written?
Yeah.
Do you have OneNote in your laptop? Microsoft OneNote. Okay, so if I will send you the notes now, so these notes will only open in OneNote.
Yeah, okay.
So now we will discuss the motion under gravity. We know that, suppose this is the pen. If I will take a pen, this pen, I'm just dropping this pen. This pen is going in downward direction again and again. Why this pen is going in the downward direction? Because of the Earth's gravitational force. Because of the Earth gravitational force, the pen is going in the downward direction.
Yeah.
The Earth is just attracting this pen towards itself by some force, and that force is known as the gravitational force or gravity. The force between the body and the center of the earth is known as the gravity. So we will discuss the motion under that gravity. Motion under gravity is simply, you can say, just a throwing of a pen, throwing of a ball in upward direction. Okay, so these are the example of, suppose this is the pen, and I have just dropped this pen like this. So basically, if you will uh, reduce the speed of the video, okay, to 0.25, so you will see that this pen will coming downward like this. Is it or not?
Yeah.
So what will happen now? This will be like this. So this pen will be attracted towards the earth due to the gravitational force, and that gravitational force is given by the Newton, and we will study the Newton's law of gravitation. And but here basically our focus will be on the motion under gravity, motion of objects under the gravitational force. Okay, so this will be our main focus here. Okay, so motion under gravity, motion under gravity we will discuss. So what is motion under gravity means? The body is moving, or body is performing the motion in a space where there is only the gravitational force present. Okay, so you can say, and this motion under gravity is also known as the free fall. Free fall. So here you can write the motion of the body, motion of body when only gravitational force is present. So just I am dropping this pen. This pen is going in downward direction due to the gravitational force only. There is no other force here. If I am neglect, okay, there is no other force now.
Yeah.
And we know that there is air around this pen. There will be the air particle around this pen. So
Yes.
what will happen when this pen is going in downward direction? These air particles will try to restrict the motion of this pen, but we are neglecting the air friction. Air friction means we are neglecting the hindrance of the air in the motion of the pen, for the motion of the pen. Okay. Suppose, for example, this is the ground. What is this? Ground. This is your ground. And here is some body. This is the body. And someone is dropping this body, and this body will go in downward direction. Is it or not? This body will go in downward direction due to gravitational force. Due to gravitational force. But remember here, this body, are you able to understand now? This
Yeah.
thing? This body is going in the downward direction due to the gravitational force.
Yeah.
But here, the acceleration of the body will be acceleration due to gravity. Obviously, because this body is coming in downward direction due to gravity. So acceleration of this body will be acceleration due to gravity.
Yeah.
Have you heard the name acceleration due to gravity?
I think.
Acceleration due to gravity, and this acceleration due to gravity is represented by small g. And the value of this small g we take 9.8 meter per second square. Okay.
Yeah. Okay.
So this acceleration due to gravity will act always in downward direction. Okay. Why this acceleration due to gravity will act in downward direction? Because body is always coming in downward direction when you will drop. So you can say the gravitational force on a body above the earth surface. If this is suppose the surface of the earth and this is the body, so on this body always the force will be in the downward direction. So that is why the acceleration due to gravity will be in downward direction. Acceleration due to gravity will be in the downward direction. Will be in downwards direction. Yeah. And one thing more I want to tell you, this 9.8 is a constant value. This 9.8 is a constant value. So you can say that motion under gravity is an example of motion, uniform motion. So you can say here, you can say motion under gravity is an example of uniform accelerated motion. Uniformly accelerated motion. Acha, Rayyan, tell me what is the uniformly accelerated motion?
Motion where it is under gravity.
No, that is right, but I am just general. I am asking what is accelerated motion? What is accelerated motion and what is uniformly accelerated motion?
Like
Hmm?
when a force is being acted upon it and it moves.
No. Uniformly accelerated motion is, this is uniform acceleration. Okay. So uniformly accelerated motion means when the body have the uniform acceleration. Uniform acceleration means acceleration is same throughout the motion. Okay. So here also here in this case, this throughout the motion of the body from this point, suppose this is A point and this point is B, and this B point is lying on the ground. Throughout the motion of the body from A to B, the acceleration on the body will be G, and G is constant. So you can say this is an example of uniformly accelerated motion. But basically, uniformly accelerated motion means motion in which the acceleration is constant. This is not the only example of uniformly accelerated motion. Is it or not? We have already taken one example here of uniformly accelerated motion. This is also the example of uniformly accelerated motion. Okay. So, Rayyan, will you take the classes on Saturday and Sundays?
Yeah, I think.
Okay. I think it will be better. Okay. So you should take the classes on Saturday and Sundays also, because other days my schedule is also little bit okay.
Yeah, okay.
Okay. So, and please remember one point. These things that I am telling you, these are very important and very basic things. Okay. If you do not know what is acceleration, if you do not know what is displacement, if you do not know what is distance, then the upcoming chapters that you are telling in your school, the first chapters is going on. You can just not learn that chapter properly. You can learn. I am not saying that you cannot learn those chapters, but if you will properly follow this, okay, understanding what I am saying. If you will properly know what is velocity, acceleration, and all that thing, then believe me, the upcoming chapter will become easier. Okay, because this is the portion that you are studying is a portion of physics, and in physics, each and every term is related with each other. For example, you are watching a movie. For example, you are watching a movie from uh, I am watching a movie. For example, okay, any movie you can take. Suppose I am watching Black Adam. There is new movie Black Adam. So if I have watched half of the movie, then I am saying, Rayyan, now see the movie. So will you get the movie? No. You will get the movie, the fighting scene and all that, but not properly. You will say what you will say. You will say that I want to watch the movie from the starting. Why? Because from the starting, when you will start, from the starting, when you will take the things properly, so your mind will be connected with each thing, and that connection will lead to you to the next chapter. Okay, and then next chapter you can deal easily. There will be no problem in the next chapter. Okay, so this is the advice from my side, but I am not saying that you should take this advice. If you like this advice, then you can take this. Otherwise, there is no problem. Okay, so you can follow your method also. Okay, so there are okay. Got it now?
Yeah.